Hello everyone. Today we're going to do another video, and this one's going to be using proportions to solve applications. So what do we mean by that? Well, you've already studied proportions. A proportion was something like x over 6 equals, let's say 4 over 9, something like that. And you would use your cross products and get 9x is equal to 24, and then divide by 9. And x would equal, divided by 3 gives me 8/3. And we would leave it like that. Okay, so that is a proportion, and we solve it with cross products because in a proportion you have one ratio equal to another ratio, and that means that if the cross products are equal, then the ratios are equivalent to each other. And so that's what we're doing with using proportions to solve applications. So now we're going to look at applications. This is a skill that is used in many ways. If you were to look at the field of biology, and in the field of biology we often talk about populations of fish, populations of wildlife, populations of various things. And we decide whether there will be a hunting season this year or not, depending upon the population that is there for that particular species. And so let us look at a word problem that actually does that. The park ranger went out to check on the wildlife, and he tagged a whole bunch of them. He caught, he caught 50 deer and tagged those 50 deer. That means it was 50 deer out of the entire population of deer. About a month later, he went out and caught 75 deer. And among those 75 deer he caught, he found 30 with tags. So, knowing this, we can now calculate what is our total population. So what we're comparing here is tagged deer to the population of deer. So our first one is 50 tagged deer to an unknown population, and this is equal to 30 tags to a population of 75 deer. So you see, we label what our comparison is because this helps us keep it straight. So we have the tagged to the total population, 50 tagged deer to an unknown number of population, and we had 30 tags among the 75 deer that were caught. And that 75 represents that whole population. So again, cross products, and we get 30x is equal to 75 times 50. Now, without even multiplying, I'm going to divide by 30 because I can now do this without a calculator, and x is equal to 10 goes into 33 times, 10 goes into 55 times, and 3 goes into 75 25 times. So I am left with 5 times 25 means that we have a population in that area of 125 deer. So you do have to label these because we are talking about word problems. So this is one form of a way to use proportions to solve an application problem. Here's another one. And this one is going to use the geometry of similar triangles. So what's going to happen here? Well, we have a big, tall tree. We don't know how high that tree is. That is our question mark, is the height of this tree. That's our unknown. And that tree casts a shadow of 30 feet. Now, partway down, at the same time that that tree casts a shadow of 30 feet, a 5-foot person cast a shadow of 10 feet. And this is a 5-foot person. So how tall is the tree? So what is being compared? We're comparing the big triangle of the tree and the little triangle of the man. So if we want to do that, we're going to compare big to little. Now, it's important that we compare the same sides that are corresponding. The tree corresponds to the man. You see, both of those are your vertical sides. So my tree is my unknown. My man is 5 feet tall. Then you're going to compare the shadow of the tree to the shadow of the man. So my shadow is 30 feet to 10 feet. Okay? So, cross products again, and you have 10x is equal to 150 divided by 10, and I have x is equal to 15 feet. So my tree is 15 feet tall. So as you can see, we can use ratios that make up two ratios equal to each other, make a proportion, and as long as we keep the same thing in correspondence, we're okay. We could have also done this way. We could have just done big triangle to little triangle and had big to little in this direction. My big triangle would be my x to my 30, because my tree is my x, my shadow is my 30, so this is tree and shadow. Okay, and over here I have my 5 feet to my 10-foot shadow. But it doesn't really matter, as you can see, because my cross products yield exactly the same thing that we had before, and x is 15 feet. And this is the beauty of cross products. If you keep your ratios running correctly, you're going to get the same answer in the two ways that you can set it up, okay? So that's how you're going to set up various proportions. And we can do them with a lot of different things. You might want to compare, it takes me 10 hours, or let's say 12 hours to drive 900 miles. So this is my miles, this is my hours. How long is it going to take me to drive 1,500 miles? So my time is on the bottom, my miles are on the top. Again, your cross products gives me 900x is equal to 12 times 1,500. Now divide by your 900, and I end up with x is equal to, well, divide by 100 top and bottom, get rid of that. 3 goes into 9 3 times, 3 goes into 15 5 times, and 3 goes into 12 4 times. So I have a 1 on the bottom, so 4 times 5 is 20. So it's going to take me 20 hours to drive 1,500 miles. So we can use these to figure out a lot of different kinds of proportions. So have fun working your proportion problems. See you later.